Assalamu alaikum everyone. Today we will be demonstrating our final year project, that is the design and fabrication of a modular and hybridized prosthetic arm. This project was done under the supervision of engineer Hamza Toor. My name is Bilal Siddique and with me are Anwar and Majeed-Ullah Khan. So let's begin. Now the problem that we are trying to address with our project is that most prostheses have limited or flawed functionality due to poor design. For example, if you take a look at the Pakistani market, we see that there are only two types of prostheses available for amputees. One is a cosmetic passive one that is cheap, and the second one is a highly functional but expensive one with a high maintenance cost. It's because of this people usually opt for the cheaper option. We hope to address this problem by designing a modular and hybridized prosthesis. Modular in the sense that it is made of easily swappable and serviceable components, each offering different functionalities, and hybridized in a way that it's constructed using different materials, each best suited for the job. What we hope to end up with is a prosthetic arm that is cheap to manufacture and highly functional, making it an appealing choice for Pakistani consumers. Let's go through a brief overview of each individual component. First of all, we have the gripper servo that provides an opposing grip motion. Next, we have the rotating wrist servo, and lastly, the elbow servo that can perform flexion and extension. The inside of the arm has mounting points for a servo bed if we wish to use the anthropomorphic wrist attachment. This gives us modularity, and similarly, hybridization is achieved by using the 3D printed plastic for custom-made structures and aluminum at points of heavy load. Next up, we have the AC to DC power supply that outputs voltage at 3 volts, 5 volts, and 12 volts respectively. We, however, are using the 12 volt 12 ampere leads as inputs to our buck converters, that is, the XL4016, which powers the elbow and the wrist at 7.4 volts, 7.5 amperes, and the LM2596 buck converter, which powers the gripper at 7.4 volts, 2.3 amperes. Then we have our rotatory potentiometers, one for each servo that we use to control their movement. Their signal is then sent to an Arduino, from where it maps it to the servo and then sends the signal to the servo signal ports. Let's see how each individual joint works. The one that you see right here is the non-anthropomorphic gripper that uses a DS3235 270-degree servo to perform an opposing grip with torques of up to 35 kilograms centimeter. Our next joint is the rotatory wrist joint. This joint too uses the same servo as the gripper and can move 135 degrees in both the clockwise and the anti-clockwise direction. The last point of actuation that we have is the elbow servo that can perform flexion and extension with torques of up to 60 kilograms centimeter. For our practical demonstration, we will be performing 3 individual tasks that are a part of our daily routine. Our first demonstration involves picking up fragile objects, for example, an egg. You can see that by using an appropriately rated potentiometer and a servo with a small deadband bandwidth, such as this one, we can perform movements in very small and precise increments and pick up fragile objects with ease without fracturing them. Our next demonstration is picking up crockery that we use every day, in this case, a mug. Here we see that the servo is able to pick up the object despite of its weight and maintain a close grip even when we lift up the object or move it side by side. Our last demonstration is a task that we usually take for granted but is quite essential in our daily routine, and that is opening and closing doors. First, the elbow servo brings up the arm to the handle's level, and then the wrist joint works in conjunction with the gripper to rotate the door handle and open the door with ease. Thus, in conclusion, we were able to achieve both modularity and hybridization in our finalized prosthetic arm that is also functionally capable of performing a variety of activities of daily living. That concludes our demonstration. Thank you very much for watching. Stay home, stay safe. Allah Hafiz.